Imagine looking out of your airplane window and suddenly, a blinding flash lights up the entire sky. A split second later, a bolt of lightning crashes directly into the aircraft. For a brief moment, the cabin goes silent. Some passengers freeze. Others grip their seats. A few begin wondering the same terrifying question. Are we about to crash? It sounds like every passenger's worst nightmare. An airplane, 35,000 feet above the ground, struck by one of nature's most powerful forces. But here's the part that surprises almost everyone. Commercial airplanes are struck by lightning far more often than most people realize. In fact, the average passenger aircraft is hit by lightning about once every year. That's thousands of lightning strikes across the aviation industry, every single year. Yet, you almost never hear about them on the news. Flights continue. Passengers land safely, and in many cases, most people on board never even realized the aircraft was struck. So, what's really happening? How can a machine made mostly of metal survive millions of volts of electricity without falling out of the sky? The answer isn't luck. It's one of the greatest engineering achievements in modern aviation. Long before an aircraft ever carries its first passenger, engineers already know it's going to be struck by lightning, not once, but many times throughout its lifetime. So instead of trying to avoid lightning completely, they designed the airplane to survive it. Every major aircraft is carefully engineered with lightning protection built into its structure. The outer skin acts like a protective shield, guiding the electrical current safely around the aircraft instead of allowing it to travel through the cabin. It's a principle scientists call the Faraday Cage Effect, and it has been protecting people from electricity for nearly 2 centuries. But surviving a lightning strike isn't as simple as wrapping an airplane in metal. Because modern aircraft contain something early airplanes never had: hundreds of computers, sensitive electronics, advanced navigation systems, and engines controlled almost entirely by digital technology. So how do airlines make sure that none of those systems fail when millions of volts suddenly hit the aircraft? That's where the real engineering begins. To understand why lightning rarely brings down an airplane, you first need to understand what lightning is actually looking for. Lightning isn't trying to hit an aircraft, it's simply searching for the fastest path through the atmosphere. Sometimes, an airplane just happens to be in that path. When that happens, the lightning usually attaches to one part of the aircraft, often the nose or a wingtip. Then, in less than a second, the electrical current races across the airplane's outer surface, before leaving through another point, usually the tail or the opposite wing. Inside the cabin, passengers might see a bright flash. Some may hear a loud bang. In rare cases, the lights may flicker for a moment, but the electricity doesn't travel through the seats or the passengers. It stays on the outside, exactly as the aircraft was designed. That protection doesn't happen by accident. Every commercial airplane goes through some of the toughest safety testing in the world. Before an aircraft is ever approved to carry passengers, engineers deliberately expose it to conditions that simulate lightning strikes. They inspect every critical system, every fuel tank, every wire, and every electronic component to make sure the aircraft can continue flying safely. Modern airplanes also contain special bonding strips, conductive materials, and carefully designed exit points that help guide electrical energy away from sensitive equipment. Even the fuel tanks receive extra protection. Special design features reduce the risk of sparks, making fuel ignition extremely unlikely. But modern aircraft aren't made entirely from aluminum anymore. Many newer airplanes, including today's advanced airliners, use lightweight carbon fiber composite materials. Unlike metal, carbon fiber doesn't conduct electricity as efficiently. So engineers developed another solution. A thin layer of conductive metal mesh is built into the aircraft's outer structure. That invisible layer helps spread the electrical current safely, giving composite aircraft the same level of lightning protection as traditional metal airplanes. It's an incredible example of engineering solving a problem most passengers never even think about. Yet one important question still remains. If airplanes are designed to survive lightning, Why do pilots still take storms so seriously? Pilots don't fear lightning nearly as much, as they fear what usually comes with it: severe thunderstorms. Because lightning is only one part of the danger. Inside a powerful storm, aircraft can encounter violent turbulence, hail, icing, microbursts, and powerful updrafts that can rapidly change an airplane's altitude. Those conditions pose a much greater risk than the lightning itself. That's why pilots don't try to fly through thunderstorms. Using onboard weather radar, they detect storm cells from miles away and simply fly around them whenever possible. Air traffic controllers also help, guiding aircraft onto safer routes long before they reach dangerous weather. Of course, lightning can still leave behind evidence. After landing, maintenance engineers carefully inspect the aircraft. Sometimes they find small burn marks, tiny pits in the metal, or damage near the point where the lightning entered or exited. If anything looks unusual, the aircraft is repaired before its next flight. Safety always comes first. So, can lightning ever bring down an airplane? The answer is, it's extremely rare. Modern commercial aircraft are built, tested, and certified with lightning strikes in mind. In fact, the last major commercial airliner accident directly linked to lightning happened decades ago. That tragedy changed aviation forever, leading to even stricter engineering standards, better fuel tank protection, and more advanced lightning testing. Today's airplanes are safer because engineers learned from the past. So the next time you see a flash of lightning outside your window during a flight, remember this: the airplane wasn't built to hope lightning never strikes. It was built with the expectation that one day, it probably will. And when that moment comes, every layer, every wire, and every system has already been designed for exactly that situation. Sometimes, the safest aircraft is the one that's already prepared for nature's worst. This has been Tech Mystery Documentary. Thanks for watching, and I'll see you in the next documentary.